Good morning, everyone. I have 92 students in the class, but it seems like 25 people sitting here. I have to start asking for fingerprint attendance. In any case, I assume that you have watched the pre-recorded video that was posted on Canvas. So I have a few questions for you before we start. So we'll be looking at that. Okay, so if you haven't done so, go to menti.com on your phone, use the code 6324165 and answer the questions. Since this is completely anonymous, you can be truthful. If you haven't watched, you can decide. Okay, so looks like large number of you have watched at least partially or completely. So now tell me, the command and control is not used for which of the following activities by the adversary, right? So I have 4 different activities here. Remember, it's not used. Okay, so suppose you are the one sending a malware to somebody else's machine, and you want to know if the malware has been installed there. How do you do that? You have to have the malware communicate to you, right? So then the first choice is that the command and control wants to know, the adversary wants to know if the malware has been installed. Then it will write the malware in such a way so that as soon as the malware finds a target and executes, it will call on the network functions and communicate to the command and control, isn't it? How else will the adversary know that the malware actually got installed? Now, once the adversary knows that that it has been installed, then it will want that the malware finds something on that machine, what applications are running, what versions are running, what are the different files in the file system, what are the, if there are any credentials somewhere in that machine, is there a weak implementation of a protocol through which it can move. So all this information the malware will send to the adversary via the command and control route. Then the adversary, based on the information it got, it will customize a payload that can exploit that particular situation that the malware is telling C2. So therefore, the second one is also something that is used, the C2 is used for, right? To get better understanding of its target and customize more virulent payload for the target. Now, if you want to do data exfiltration, let's say you want to exfiltrate data from another person's system using a malware, how will that malware send the data? Where will it send the data? It will read the data from the target machine, but it has to send it somewhere. So that has to be a command and control server, right? So all these 3 choices are not correct, because I am asking which one of this is not an use of command and control, right? I am not asking which one is a use of command and control, because that would make sense, because I have 3 different choices, all of which are actually use of command and control. So the last one, the privilege escalation, is the natural choice, because privilege escalation is nothing to do, it's a very local thing. It has nothing to do with what happens there, like in the command and control side. If there is a weak program which has a privilege escalation vulnerability, and your homework 1 will make you do a privilege escalation. So you will understand how privilege escalation happens, right? So in terms of homework, you will get virtual machines which you will have to install on your machine and do all these things, right, on that virtual machine. Okay, so next one. So this is an easy one. Use your finger to push up and down and sort them in the order in which they appear in CKC. So these are the 7 stages of cyber kill chain. They are in a random order. So you have to basically push them up and down to put them in the right order. So I see there are not many responses yet. It's almost correct. It's almost correct. Where is it not exactly correct? See, you have to do exploitation of a weakness in the system before you can do installation, right? So your exploitation and installation order for majority basically is in the opposite order, but otherwise you got the other ones right, but this one has gotten a little bit, in the reverse order. Okay, so now go to the next one. Here I am asking, like, suppose you disrupt. Remember, like in CKC 7 stages, and claim of CKC is that if your defense can actually stop them in one of the 7 stages, then you win, right? You cannot get it, the adversary do the final thing that it wants to do. Now the question here is that whether you stop it or not, you have to do post-incident analysis, and there are 3 reasons given why, and you have to basically say which one is more important reason why I would like to do the post-incident analysis, and not be happy that okay, the bad thing didn't happen, all's well that ends well doesn't work, right? I mean, here you have to actually analyze why it could actually do what it could do. Okay, so this ordering is not, it's rather subjective. Of course, you have to know where the defense failed, right? And then you have to fix that, because your defense must have failed in one of, at least whichever stage, up to whichever stage the adversary could come in. Until that stage, your defense didn't work, at least against that particular adversary. So you have to figure out what failed and then accordingly fix those. Now there is a you can debate about second and third, which is of course you need to learn more about the adversary, but also you have to do root cause analysis, and in a well governed cybersecurity environment, every incident root cause analysis is presented to the highest authority, in order for for the highest authority to know where the possible risks are in the organization, right? So that's kind of you can have second and third kind of a risk condition. Now this one I have put intentionally, I haven't really told you about all possible APT groups, advanced persistent threat groups. I have said that advanced persistent threat groups are very resourceful threat groups, usually supported or funded by nation state governments, and it's actually quite difficult to tell whether a particular threat group is working for a specific government. This process is called attribution. So it's an attribution is difficult, but there are some which are which have been analyzed by a lot of threat intelligence companies, and there are we kind of know which one is correct, and some of them we do not know as fully correct. Okay, so in this case, so I wanted to see if you got interested beyond the class and actually did some studies about this nation state adversaries. In any case, APT28 is not a Chinese APT, it's actually a Russian APT. They were responsible for the SolarWind attacks in 2020 in the US. Many US government entities, their organization were infiltrated by the supply chain attack on a software system that's for network monitoring called SolarWind. So APT28 is not a Chinese group, so most of you have avoided that. And indeed APT3 is a Chinese threat group, right? So most of you have looked at that, so that's good. Now for each of these you have to say whether it's true or false. So well, first one I have already disclosed. So for the other two, so APT28 nobody got wrong. So APT37 indeed is a North Korean group, and sometimes it is considered that this is also the same as the Lazarus group. They actually go after countries like South Korea, US. They have been found in India also. They are pretty resourceful, very skilled set of hackers. APT33 is also correctly in Iranian group, right? So APT33 is an Iranian hacker group. As you can imagine that countries like North Korea, Russia, Iran are some of the most and Chinese are some of the most notorious threat groups. They have multiple different threat groups, not just one threat groups. Now remember that when I say something like APT3 is Chinese threat group, right, and APT1 is also a Chinese threat group, it may be in reality that the APT1 and APT3 might be the same set of people. Based on the attacks they use, the malware they use, the command and control infrastructure they use, the kind of targets they actually choose, all these things allow a threat intelligence company or organization to cluster these attacks, many attacks together and name them as a APT group. Now it may so happen that what we are calling APT28 may be actually two different groups who are all using similar set of malware, similar set of attack modus operandi and so on. Or it can also be the case that APT1 and APT3 are the same group, thus they are using two different sets of infrastructure, two different types of malware, two different types of things. So all these things are shrouded in mystery, right? So we do not really know that that APT28 is being directly talking to, for example, Putin, right? We do not know that. But the threat intelligence companies over time have analyzed and found that they found fragments of Russian language comments in their code. They found command and control infrastructure that are not necessarily in Russia, but actually have been found to be used by Russians in other places. They also find that this time of the day when they were most active. They also find the targets that they choose, like Ukraine, US, these are mostly their targets. From that they actually came up with this idea that this is Russian. Now in India we do not have this capability of attribution. So in CCA Hub we are doing a lot of work on this attribution, but in general we haven't developed this attribution capability so far in India. the last question. So this is a book I already mentioned. This is a book by New York Times Cybersecurity reporter. If you remember, well, you are probably too young to remember. How many of you heard about Snowden? So Snowden was a consultant employee in the, I believe in Booz Allen Hamilton, which is a defense contractor. And then he exfiltrated a lot of data during early 2000s about many secret programs that US military and the intelligence agencies were doing, including spying on its own citizens. So what he did is that he then gave this information to certain news organizations. New York Times was one of them, and Nicole Perlroth worked on that team. And since then she found that there are a lot of programs by governments, and not necessarily only Russian and Chinese and Ukraine, the usual suspects. It's not only the usual suspects. It's actually governments like the US government, like our government, like the European governments. They all have programs to find vulnerabilities in, and of course Israel, find vulnerabilities in very highly used software systems, right? For example, in iOS or in Android or in Windows or in Windows Office or things which are widely used. And governments buy these vulnerabilities from hackers who are black hat hackers, who are not necessarily considered responsible hackers. So responsible hackers, they actually go and when they find a vulnerability, they do what we call a responsible disclosure. They go and tell the company, look, you have this problem, I'm going to publish this in Black Hat conference or whatever conference, but I will wait until you fix it, right? So that's what is responsible disclosure. They won't disclose it to the world until it is fixed. Unfortunately, the Black Hat hackers are the opposite. They find vulnerabilities, but they do not disclose to the organization that is responsible for that software, hardware, etc. They will go and sell it in the black market. And one of the biggest buyer of this black market are governments. So governments actually buy these exploits, for example, National Security Agency in the US, and then they actually use it, right? So use it against other countries, like important personnel, like their prime ministers or whatever this is. And now there are companies who actually also create this, use this exploits and create a complete command and control system. So you can buy the entire command and control system from them. And one of these famous company that you might have heard of is NSO, right? NSO is the company that was responsible for Pegasus. Pegasus was a malware that was a zero-click and zero-day malware, and they basically sell to the governments this whole command and control infrastructure through which you can actually see what is happening in somebody else's phone, and actually from that you can spy on them, right? You can spy on them. You can also put in incriminating evidence in their phone or in their desktop, etc., which will later on be used against them. So there is a whole business around these vulnerabilities and exploits. There are also open companies where you can find, not even in the dark web, in the regular web, surface web, there are companies which will pay you over $1 billion if you find an iOS vulnerability that is zero click and 0 day, right? So this is the situation. So what this book basically says that, we already have seen Stuxnet being used by other countries in Iranian nuclear plants. What stops Iran to use the same on other countries? And they have tried. And Iran has actually attacked dams, water, like the hydro systems in the US. By mistake, they did a very small dam, so it didn't work. But the same named dam was also in Oregon. If they had done the same attack on that, then thousands of people would be flooded away, right? If the gates open in the dam by remote control. Similarly, the North Koreans are doing this all the time to South Koreans, and Russians are doing this to Ukraine. They did shut down their power and various things. So what this book is saying is that if we do not have control on this, we are going to basically at some point we'll create a nuclear disaster or some kind of a weapon system misfiring, and that could create an entire worldwide war, and the world may end. This is a very dystopian view of things. I don't want to scare you, but it's a serious thing to be taken very seriously, and I would highly suggest reading this book if you can. If you try hard, you will find a PDF copy somewhere on the internet. But I would request you to not use that and buy it. It's not very expensive. It's like 500 rupees or something in India. Okay, so now I'm going to start our new module, MITRE ATT and CK. So MITRE ATT and CK is a knowledge base of how adversaries attack our systems. And to remember, like in CKC, what we saw is that they said they are very simplistic. They said these are the 7 stages through which an adversary has to get into your system, install things, make it permanent, persistent, then may actually go into communicate to the command and control, then eventually do something that is harmful, right? So MITRE actually came much later than CKC. So they actually analyzed, thousands and thousands of attack incidents, papers and so on, and they said, okay, this is not as simplistic and as linear as CKC might give you an idea of. So so they created a knowledge base. Now this knowledge base is actually very extensive. It has 14 tactics and over 300 techniques, and then more procedures, right? So it's basically what is called TTP, tactics, techniques, and procedures. So so we'll talk about what this ATT and CK is all about, and then we'll teach you how to map an incident, like an attack incident, into ATT and CK framework. And we can do it from reports from analysts, or we can do it from raw data, the data that we collect as evidence from there. And then we'll talk about a tool that MITRE has provided to do this kind of work. And then we'll see that, of course, this is not to teach you how to attack. This is actually for defenders to understand the attacker so that they can actually figure out for each of these techniques if my defense is adequate or do I have to do something else. So to kind of wrap your head around what can happen to my system and figuring out how would I stop or how would I detect that when it happens. So as a defender, I want to know various things, right? So I want to know whether my current defense is adequate, right? And the controls that I have, like I have firewalls, I have endpoint detection, I have network monitoring, I have strong authentication, I have two-factor authentication, I have network segmentation, I have all these things, but is this enough? So if the question, is this enough, can only be answered if you know what the other side can do, right? If you assume that the other side is very stupid, they will only try to do something that phishing and nothing else, right? So then of course you do not have to do a whole lot, right? You can stop that by giving a lot of training to your employees and users that don't click on this kind of things, don't download this kind of things, and continue to say such things, and you will be fine. But the adversary is not simple, right? So they are much, like as I said, that they are backed by governments, have lot of funding, lot of good hackers work for them, and so on and so forth. So therefore, I cannot really depend on this small or ad hoc implementation of defense. Like sometimes people do not think about adversary and all, they just put a firewall, they just put a proxy, and they just put some antivirus and think that everything is fine. But actually it is not until you actually figure out what the attacker might do and then compare whether you have adequate defense. So that is something every defender wants to know. And then second thing is that let's say I read in the news that educational institutes are now being targeted by, let's say, APT X, right? So sometimes, like they attack, some APT groups target health sector, some APT groups attack the oil and gas sector, and some nuclear plants. So there could be an APT group which might be attacking, let's say, educational sector. So as IITK, I will be then immediately worry about whether I can be a target, and if I am the target, I have to read all the information from other incidents, how they got in, what did they do, whether they did any kind of data exfiltration, whether they do ransomware attack, and so on. Then I have to check whether against all my defense controls, whether I can handle that particular APT. So this question here is not just about APT 3 or let's say 29. 29 is also Russian, 3 is Chinese, but actually this for any kind of threat intelligence that you get in the news and from let's say CERT or other places, that this APT group is now focusing on this particular sector, then I have to check against my defenses whether that APT group can be thwarted by my defenses. And to do that, I have to understand what that APT group does. So this is the question, like, can I stop APT attacks? And then the other question is that when I collect, so organizations collect a lot of data from their own infrastructure, right? So for example, if they have a network monitoring, they have a endpoint monitoring, lots of data, logs from all the systems, firewall logs and web server logs and so on. So it's a huge amount of data we collect, and then we analyze it and we display the main findings on a screen, like in an SOC. Now the question is that data that I am collecting is useful in protection, detection, or response, right? So this is the other question that I may have. The other question is that, am I actually overdoing it? Am I actually having many tools which have overlapping functionality? They are meant to do the same, they are meant to detect, or they are meant to defend against the same thing. Maybe I am just unnecessarily buying two different tools, paying their license fee and so on. So that's another question I may want to know. And then other thing is that when the vendors come to you, the cybersecurity tool vendors, they will tell you all kinds of things, right? So, but you have to actually, formulate the right questions in your mind, that what is this tool for? With respect to this type of adversarial activity, will this tool help? And this kind of questions can be answered better if you actually think, formulate everything in terms of MITRE, ATT and CK. So these are the reasoning why MITRE, ATT and CK was created, right. So ATT and CK is a knowledge base. It's actually not a tool, it's a framework to actually think and study the adversary's behavior in a very structured way, right. As I said that this group, MITRE Corporation is a think tank. They have a group, they formed a group, and this group actually went through a very large number of incidents and what happened in those incidences and what was done and so on. And then they came up with this structured way of capturing all these incidents, right. So they said an adversary actually has a final goal. Like for example, in case of Stuxnet, the final goal was to actually change the program of programmable logic controllers such that the motor that rotates the spindles for enriching uranium, this motor sometimes goes very fast and sometimes goes very slow, and instead of going in an uniform speed and at a critical speed, right. The whole nuclear enrichment, they had like thousands and thousands of very large, tubes in which uranium was being rotated for this enriching the uranium. So these spindles, if they rotate at a critical speed or beyond a critical speed, only then it works. That was the whole idea. Now what these attackers did is that they said, okay, so who rotates the spindles? There are motors, right. Every spindle has a motor, right. So that motor rotates the spindle. So they said, okay, fine, so what I'll do is I will see how I can get to the PLC, the programmable logic controller, which tells the motor to run in what speed and so on, right. So which basically gives signal to the motor, sets its speed and so on. So how do I get to the PLC, right. So PLC is actually is within the within the the place where the spindles are situated. It's like a factory floor, right. So these PLCs are now actually being controlled by SCADA systems. These are supervisory control and data acquisition systems. But PLCs are not like regular computers. You cannot sit on them. There is no screen. There is no like LCD display. There may be a small display and stuff, but there is no large display and there is no keyboard and stuff. So you actually create the PLC programs and download them into the PLC, right, from Windows machines. So if I need the PLC program to change, then I have to actually go to find those Windows machines from which the PLC program is loaded, right. Now how do I get to that Windows machine, right. So that Windows machine is within the network, but that network itself is not connected to the internet. So but within this network, the office network at which regular officers were working, and the network on which that Windows machine was there, from which the PLC programs are loaded, were in the same segment, same network segment. So if I can get one of these office guys to carry the malware is written very carefully and with lot of the ground intelligence, right. They knew exactly which, like it was a Siemens PLC that they were using, an S7, right. So they knew exactly make and model and how it works, how the PLC is loaded with programs from Windows, all this stuff they researched. So they then apparently they gave some free USBs somewhere or something where the actual malware was loaded, and one of the officers actually brought that in, plugged it in, the malware got copied into his machine, same network, by utilizing the connection between one machine to the other, it did a lateral movement, and then it actually went eventually to find the machine where the PLC program is loaded. It replaced the PLC program by a program that will make the motor run erratically, and these motors are very sophisticated, so if they run erratically for a while, they burn out. So the main idea was to actually burn out as many motors in a very short time as possible, again and again. And the attacker, the defender, is thinking, so motors often crash and burn, right? So, but that percentage is very small, like maybe 1% motors also crash and burn quickly. So when they started seeing that motors are crashing and burning, but they saw that this crash and burn is a very fast rate, like very large percentage of motors are crashing and burning, which basically halted their uranium enrichment program. Then they realized something is not right, and then they did the analysis. They looked at the PLC program and they say, this is a different program. This is not a program that was already there. Then they worked it out, and they figured out that they have been taken in for. So at this point, they actually started. They figured out, and they started launching the same thing, Stuxnet, everywhere else. So in a couple of months, after the Iranians got to know, in a couple of months, Stuxnet was found everywhere in Europe, then in US, South America, and also in India and Asia, right? So within like that year, we are seeing Stuxnet everywhere and various variants of Stuxnet, right? So at this point, the governments who actually did this, they got really afraid that, okay, we have launched something, we have unbottled the genie which cannot be put back into the bottle. That is the situation. Like, so we thought that we'll just do it, nobody would know, we'll delay their nuclear program, and they will not figure out how they were having so many motor malfunctioning for a while. They will replace it. By then, we have a large gap between their in the advancement of their nuclear program. But unfortunately, the thing came out in the open, and there are various variants of Stuxnet started coming, and also various variants of other malware, which seems to be from the same group that actually started the Stuxnet malware, and it got forked into multiple different types of malware. I have a whole lecture on that. I will post that. So the idea that I am trying to tell you is that the adversary has a eventual goal, that is to destroy their nuclear capabilities by delaying it. That is their final goal. But they don't get to the final goal just directly, right? You cannot attain the final goal directly. So what you have to do is that you have to do various short range goals, right? How do I get in, right? So this system is not connected to the internet, so they don't read emails on their computer, so I cannot phish them. So I have to figure out how to deliver the malware. So USB it is, right? So once they got that, they got one goal done. But before doing that goal, they also had to do weaponization, because to write that Stuxnet worm was a lot of work, probably years of work, right? So weaponization was done, and then the reconnaissance, which executives to actually target, that I have to figure out, right? So that also I have to figure out. So reconnaissance was done. So reconnaissance was done, weaponization was done. In fact, reconnaissance was probably done after weaponization, right? Because you write the Stuxnet in the lab, you test it on a test bed, then you go and find who in that particular facility is amenable to taking a USB inside without suspecting anything. So that is reconnaissance. Then we find the delivery. Delivery was through the USB stick. Then that worm has to actually figure out the machine in which that worm was initially executed. It may not be a high privileged account, right? So it has to figure out maybe how to do privilege escalation, or it has to figure out how to move across that machine to another machine, eventually in search of the machine that has the PLC system. So these are small goals, right? So how to get in, how to move from one machine to the other, how to collect the data about which machine has the right target system. All this stuff has to be done, and these are called tactics. So when an attacker eventually wants to execute a goal, he has to string together tactics, right? And these tactics are not necessarily in a linear fashion. Like as I said, in Stuxnet, probably the reconnaissance happened after weaponization, right? So tactics do not happen in a linear order, they may happen in multiple order. Same tactic may be used multiple times in the same chain of events, but eventually you want to execute the final goal. That is what this thing is about. So tactics are then, now to implement the tactics you need techniques. So there are a lot of different techniques you can use. For example, delivery by a USB is one technique for delivery, but you could also deliver it through a CD. Maybe you could have delivered it through email. You could have delivered it through some other mechanism, like finding a weakness in their local network, and by sending a spy into the facility. All kinds of stuff can be actually done. So each tactic has a multiple techniques by which that tactic can be realized, and then techniques can be described in terms of procedures, how a technique is actually applied. So there are procedures. So, and this knowledge base is community driven, so it's not like done only by MITRE people. They invited everybody to actually contribute to this, and it has become a very huge and very useful knowledge base for everybody. Okay, so let me show you the knowledge base, because I don't think I have a whole lot of time here. 5 minutes. So attack.mitre.org is where you have to go. Here you will see the tactics, right? So tactics, here you see the tactics that I am going to talk about in the class is enterprise tactics. So enterprise tactics, there are 14 tactics, right? Now if you go into their mobile tactics, how mobile attacks on mobile phones happen, then you will see a slightly different set of tactics. And if you go to their ICS tactics, that is industrial control system, then you will see a slightly different and a smaller number of tactics. Doesn't mean that the attack on ICS requires less number of tactics, but so far the attacks that have been analyzed has seen only these tactics. Tomorrow there may be another tactics added to this list, but so far this are the tactics that have been seen in use. Then if you actually go into the techniques, so enterprise techniques, so here is a list of techniques. There are 300 plus techniques. So here, and then there are sub techniques. So for example, here you say that abuse elevation control mechanism, right? So here this is about privilege escalation, right? So there are multiple different sub techniques within privilege escalation, like those of you who know about set UID, set GID thing. Here is the bypass of user account control, using sudo or pseudo caching, elevated execution with prompt, temporary elevated cloud access, access token manipulation. So there are many different ways you can actually do the privilege escalation. Okay. So similarly, you can have techniques that are associated with, let's say, initial access. So initial access, you can have content injection, drive-by compromise, exploit public facing application, external remote services, and so on. So these are techniques. We'll get into this later, but this threat intelligence, right? So there are threat groups. So you can see all these different threat groups, like we talked about, say, APT1, right? So APT1 is a Chinese threat group attributed to the 2nd Bureau of People's Liberation Army, General Staff Department's 3rd Department, commonly known its military unit cover designator as Unit 6, 61398. So this group has been analyzed quite a bit by the various threat intelligence agencies. So that's why they are being so specific, right, about who might be behind the APT1. Some of the groups may not be actually, known that definitely. Here you have all the techniques that has been seen to be used by this APT group, the kind of software they use for their attacks, and so on. And then there are some of this analysis and stories related to APT1. So this is where you find more information of APT groups. You can find about different softwares used for attacks. So you can see, and this list continues to grow as we know more. Campaigns. There are campaigns which are basically what the APT groups carry out. So if you want to know, how the 2015 electric power attack, then you can go here and you can actually see what techniques were used, and then you can, from that you can figure out what tactics were used. So you see that these are some of this software that were used for this Ukraine electric power grid attack, and there are so many of these techniques were used. So we'll stop here.